Well, welcome back to another exciting math topic. We've got four little topics we're going to cover today. One is the sum of the roots, the product of the roots, the discriminant, and then we're going to talk about zeros of some graphs. So sum, product, roots, and discriminant. Take great notes, and we look forward to seeing you. So let's start off with topic 1 here, roots of quadratics. So one of the first things we'll need to know is the formula for sum of the roots. And maybe you have this down by now, I would hope so. But just a reminder, the formula for sum of the roots is negative b over a. The formula for product of the roots is c over a. And I guess I should slow down and just recall that the quadratic equation looks like ax squared plus bx plus c equals 0. So the a is with the x squared term, the b is with the x, and the c stands for the constant that's by itself. Now sometimes you may not have a b or a c, and that's okay, you just use 0 in their place. Lastly, how do you write the quadratic equation given two roots? Well, the formula goes x squared minus the sum x plus the product. And of course, don't miss the equals 0. Make sure it's an equation with an equals 0 on the end. So let's go ahead and dive right in. Question 1. 4x squared plus x minus 3 equals 0. Find the sum of the roots, and b, find the product of the roots. So it's pretty straightforward. We just need to know those two formulas and be able to keep them straight. If you're not familiar with them, make yourself some flashcards. So the sum is negative b over a. And then I'll just go through and I'll just say to myself, okay, the a is with the x squared, so I know a equals 4. B is with the x. Now remember, if you don't see a number there, there's really a 1 in front of every x. And the c is the constant by itself, which is a negative 3. So I would say I have whoops, slow down. I lied there. My b value is going to be negative 1 over 4. So I'm literally just saying my b over my a. Product of the roots, so again, just jot your formula down, c over a. Okay, so I'm just going to grab my c value, which is negative 3, over my a value, which is 4. And it's that simple. Number 2, we'll make it a little more interesting. Now we have to write the quadratic equation whose roots are 6i and negative 6i. So look back in your notes and let's write that formula down again. The formula was x squared minus the sum x plus the product equals 0. Okay, so again, maybe you need to make a flashcard, but let's make sure we have that memorized today. So basically, you just say to yourself, well, I need the sum and I need the product. Well, if my one root is 6i and my other root is negative 6i, what do you get when you find their sum? Well, that just means add them together. And 6i and a negative 6i make 0. So I would say 0 is the sum. If I want the product, I'm going to take positive 6i and I'm going to multiply it by negative 6i. So 6 times 6 and negative 6 gets me negative 36. I times I is I squared. I can keep cleaning that up because we know about our imaginary numbers. I squared is negative 1, which gets me a product of 36. So now I'll just carefully plug them in. So it starts with x squared minus the sum x. Do I need anything here if it's 0? No. And plus 36 equals 0. And there you have it. This quadratic equation should have two imaginary roots that are positive 6i and negative 6i. Let's try another one of those. Number 3. Which quadratic equation has roots 2 minus 3i and 2 plus 3i? Alright, so again, I'm going to write the equation. So I'm saying x squared minus the sum x plus the product equals 0. So the two things I have to find are the sum and the product. So sum literally means add. So I've got 2 minus radical 3, and I'm going to add to that 2 plus radical 3. The common terms are 2 and 2, which make 4. And a negative radical 3 and a positive radical 3 are a wash, they make nothing. Then I need my product. So I'm going to take 2 minus radical 3 and multiply it by 2 plus radical 3. Alright, so a little foiling. First, outer, inner, and last gets me negative radical 9. So I've got 4. These two wash. square root of negative 9 is 3, so minus 3 equals 1. So now as I put it all together, I should get x squared minus the sum. So it's always a minus sign, and then put your sum in there. So minus 4x plus my product equals 0. And there you have it. Number 4. Find the quadratic equation that has a root of 2 plus I. Well, notice I only gave you one root. You've got to be able to come up with the other root. So let's make a star in our notebook. If you know one root, the other root is always the conjugate. Okay, the other root is always the conjugate. So if one root is 2 plus I, what is the other root going to be? 2 minus I. And now we'll do the same two things. Find the sum and find the product. So pause it, see what you get, and then write the quadratic equation. Well, hopefully you can follow my work. My sum was 4. My product, when I FOILed, I got 3. And there's my quadratic equation. X squared minus the sum x plus the product equals 0. So here's a little twist. If the equation x squared minus kx minus 36 equals 0 has x equals 12 as a root, what is the value of k? Okay, so here's what we do. We say to ourselves, do we know the product or the sum? And take 2 seconds and let's write down each. Remember, the product is c over a, so if I look at this, I'm going to get negative 36 over 1, which is negative 36. And I know the sum is negative b over a, so if I plug this in, I'm going to get, let's see, a negative k over 1, which is k over 1. So which one do you know? Well, 36 makes a lot more sense than k does to me. I know the product is negative 36. So here's what I say. Product means to multiply. So I know root 1 times root 2 has to equal negative 36. Well, one of the roots is 12 times something has to equal negative 36. And if I just divide out my 12, I know that my other root is negative 3. Now, does that answer the question? Well, basically that tells me the other root. Remember, you want to know what k is. So at this point, it's very simple. My two roots, I had one root of 12, and I just said my other root is negative 3. And we just verified that we had a product of 36, and all I have to do is find their sum. Their sum equals 12 plus negative 3, 9. So now I'll use my sum formula that we found. We said our sum formula was k over 1. So k divided by 1 has to equal 9. Little cross multiply, k equals 9. And there you go. We found the value of k. Let's try one more. X squared minus 6x plus k equals 0. If one of the roots is 4, find the other root. Alright, so I'll start with the two things I always have, my sum and my product. Sum, negative b over a. So in this case, notice my b is negative 6, so a negative 6 is a positive 6 over 1. So I know the two roots are going to add to 6. My product is c over a, which in this case is k over 1. So I don't really know my product, but I do know the sum. I know that the two roots have to add to 6. And they told me one of the roots is 4. So I know root 1 plus root 2 has to equal 6. One of the roots is 4. Can you easily figure out the other root? Hopefully you're telling me the other root is 2. Okay, so in this question, it actually just said find the other root. But let's spice it up, and now let's find the product. Okay, so all I do is I say, okay, that's root 1 times root 2. And root 1 we said is 4. That was given here. We found our second root to be 2. That means their product is 8. So what does that tell me? Well, I'm going to set my product equation equal to 8. K has to equal 8. And there you go. Alright, our next big topic to cover is the word discriminant. And the discriminant describes the nature of the roots. I like to really highlight those D's there. The discriminant describes. That means you need words to describe them. So there's a formula we use before we can start writing these words down. And the discriminant formula is b squared minus 4ac. Now, you'll notice that should look familiar. That's actually under the part under the radical in the quadratic formula, right? B squared minus 4ac. All right. So let's go ahead and make this table in our notebook just to identify the nature of the roots. So I'll try to go nice and slow here. Take a few moments to copy all this down. Basically, we're going to describe a few cases for our discriminant, the nature of the roots, and then what the graph should look like. So the first case is if b squared minus 4ac, the junk under the radical, notice not including the radical, actually equals 0. We would describe the roots as real and equal. Alright, so we have to know that if the discriminant equals 0, the roots are real and equal. And the graph will look like this. Notice there's only one x-intercept. It's only going to touch the x-axis once. And the word in geometry that you use to describe that is we say it's tangent to the x-axis, when it only touches once. Okay, our second case is that b squared minus 4ac, try to draw a line in here, is less than 0. Okay, if you are less than 0, that means you're a negative number. And remember, if you're negative and you're underneath the radical, that means you are imaginary. Okay, you are an imaginary number. And think about it, because b squared minus 4ac is under the radical and you just got a negative under there, it should be pretty obvious that you're imaginary. And what does that mean for us graphically? Well, if you're imaginary, you should not be touching the x-axis at all. There are no roots. They're imaginary. You can't see it touch the x-axis. Now the big one. B squared minus 4ac is greater than 0. There are two things that can happen. Your number could be a perfect square, or it's either not going to be a perfect square. So you either are perfect or you're not. And here's the case if you're perfect. Okay, if you're perfect, you are a real number. You are rational and unequal. Okay, real, rational, and unequal. I tend to remind myself that perfect things are rational. That's kind of how I remember it. If you're perfect, you're kind of a rational thinking person. And here's what the graph would look like. Okay, you can clearly see that it has two x-intercepts. Now, I don't know what they are, but there's two of them. 2 times it hits the x-axis. And then my other option is if I'm not a perfect square, watch what changes. I'm still real, okay, but I'm not rational. I'm not perfect anymore. So if I'm not rational, we call that irrational. And I'm still unequal. Alright, so a couple things to remember. The only time you use the word equal is if it literally equals 0. None of these other ones have equal signs. So the only time I'm equal is if I'm equaling 0. Everybody is a real number unless you're negative and imaginary. And that, I think, is pretty obvious as well. Rational goes with the word perfect, irrational if you're not perfect. So next example, the roots of this equation are, and they're looking for you to describe it. So you just have to know, if they want you to describe something, that means in your head you have to use the discriminant. So we'll squeeze it in there. So I'm going b squared minus 4ac. And I'm saying to myself, okay, my b is 3. So notice my parentheses squared, minus 4 times 9 times negative 4. B squared minus 4ac. So this gets me 9. Oh, this will definitely be a positive, and 144. If I add those together, I get 153. Alright, so now I have to describe it. So if you look back at your table, clearly you're not 0 and you're not negative, so that rules out the equal and the imaginary. Are you a perfect square or are you not a perfect square? That's basically your only question. So since I'm not a perfect square and I'm a positive number, I am real. Okay, not a perfect square is telling me irrational. And unless I'm equal to 0, which I'm clearly not, I am unequal. And that's all they're looking for. Let's try another one real quickly. The roots of the equation are, so again, they want me to describe, which implies use the discriminant. which is my b squared minus 4ac. All right, pause it, plug it in, and see what you come up with. All right, I've got 100 minus 100, which is equal to 0, and because it's actually equal to 0, this is the one time I get to use the word equal. I have equal roots. It's not a negative number, so it's also a real number. So I have equal and real roots. All right, let's take a few moments and just try to describe the graphs, what we see, what type of roots they have. I'm going to start with option 1 here. How many times do I touch the x-axis? How many roots do I have? Well, you'll notice you are touching the x-axis once, so I'm going to say that's one root. All right, I'm touching it once. So if I am touching it once, we said that's tangent to the x-axis. And that means I actually have two roots. They just happen to be equal. So I would describe this as this graph is an equation with equal roots, and they are clearly real because I can see it right there. Let's describe the second graph. Okay, I can see I have two roots. Okay, they're not imaginary. I can see them, so they are real. They're definitely unequal. This one's negative something, this one's positive something. And now, I'm not 100% sold on whether I'm rational or irrational at the moment, so we're going to leave it like that. And this last graph, I hope is very, very obvious. Can you see any roots on this x-axis? No, that means it's an automatic imaginary. Alright, we cannot see the roots. Next, for which example of m will the equation 4x squared plus mx plus 9 have roots that are real, equal, and rational? So now, they kind of went backwards, and they want you to use your discriminant formula, but they're telling you what it's supposed to do. If you are real, equal, and rational, the key word to me is equal. The only time I'm equal is if my discriminant, b squared minus 4ac, actually equals 0. So that's what I'm going to do. I'm going to set this thing equal to 0. So I've got my a, my b, and my c, so I'm going to say m squared minus 4 times 9 actually equals 0. M squared minus 144 equals 0. I can quickly factor this because 144 is a perfect square. M minus 12 and m plus 12. And if I tee that up, I should get m equals 12 and m equals negative 12. Now you notice it says for what positive value of m, so I'm going with m equals 12. Alright, let's step it up a little bit. For which value of c will the roots of the equation be real numbers? Now, they didn't give you 3 words to describe it, they just said you're going to be a real number. Well, what's true about your discriminant if you're a real number? Okay, are you equal to 0, less than 0, or greater than 0? Well, I think in my head, if I'm less than 0, I'm imaginary. Therefore, I have to be greater than 0 to be real. And now I'll just plug them in. I've got my negative 4 squared minus 4 times my c value is actually c, is greater than 0 because I'm solving for c. So I've got 16 minus 16c is greater than 0. I'll keep solving. I'm going to subtract my 16, so I've got negative 16c is greater than negative 16. Notice I'm going to divide by a negative, so what do I have to remember to do? Flip that bad boy. So I've got c is actually less than 1. So what values of c will work? Well, basically any c that is less than 1 would, so think about this answer, would 1 work? Well, heck no, it doesn't say c can be equal to 1, c has to be less than 1. So 0 could work, negative 1 could work, negative 2 could work, and of course there'll be multiple choice. But just make sure you read that c has to be less than 1. Alright, our last tiny little topic here is called roots or zeros of a polynomial. And our definition is where the function crosses the x-axis. So it's a simple multiple choice question. We've seen it almost every year. Just where does the graph cross the x-axis? And there's 2 ways to say it. They can either use the word root or 0. So if you take a look at this graph, first of all, how many times does it cross the x-axis? I would say 3. 1, 2, 3. And sometimes they'll just say how many, so I could say 3 times. Sometimes they'll ask you to approximate the roots or zeros. So let's give it a go. This one doesn't actually hit -1, but I would say maybe -1.7. This one hits right at +1. This one hits close to 3, maybe 2.7. But I would say there are 3 roots, or zeros. Next question. By observation of this graph, how many real roots does this equation have? So again, I just want to stress they're either going to use the word roots or zeros. Okay? And basically, why do they say 0? Well, the 0 describes the height from the x-axis. How high is this graph from the x-axis? Well, if it's right on the x-axis, it's 0 height. So again, I would say I have 1 here, 2, 3 roots. Okay, so I'm going to say 3 roots or zeros. And, if they asked me what they were, I could kind of guesstimate them. But at the moment, I just need to know that my roots are where I cross the x-axis. Well, that does it for us tonight. Have a great night. We'll see you tomorrow.